Hey Walkets, today we're looking at journal page 44, Quadratic Inequalities. Graphing quadratic inequality steps. Step 1, graph the parabola using the X-Intercept and the Vertex. Step 2, use a solid parabola for y is less than or equal to and y is greater than or equal to, and a dashed parabola for y is less than and y is greater than. Step 3, shade above the parabola for y is greater than and y is greater than or equal to, and shade below the parabola for y is less than and y is less than or equal to. If you would, go and complete your notes. All right, now your notes are completed. Let's take a look at the examples. Okay, now in our notes, it says that we need to find the X-intercepts and the vertex. Okay, so let's do that first. Now, let's go and find the X-intercepts first. Okay, so to do that, we need to set 2x squared minus 4x minus 6 equal to 0. Okay. Now, to make this problem simpler, we see that we can divide each of these numbers by 2. So let's divide everything by 2. Okay. Now, 2 divided by 2 is 1, so that's x squared. We don't have to put the 1, we just say x squared. Negative 4x divided by 2 is minus 2x. Negative 6 divided by 2 is minus 3, and then 0 divided by 2 is 0. Now, to solve this, we're going to factor using the reverse box method. So first term, last term, and these two need to combine to be negative 2x. All right? So now we need to find all the combinations to make negative 3 and combine to be negative 2. But before that, we can go ahead and know that x times x is x squared. Okay? So we know that 1 times negative 3 is negative 3. And then 2 doesn't work. 3 times negative 1 is negative 3. And those are time symbols. And those are negatives. All right, so then 1 minus 3 is negative 2. That works. So our factors are x plus 1 and x minus 3. And let's check to make sure this works. X times 1 is 1x. Negative 3 times x is negative 3x. Negative 3x and 1x combine to be negative 2. That works. Okay, so now we need to set x plus 1 equal to 0 and x minus 3 equal to 0. Okay, now we're going to subtract 1 from both sides, so x equals negative 1. And we're going to add 3 to both sides, so x equals 3. Now, since those are the x-intercepts or zeros, the points are negative 1, comma 0, and 3, comma 0. Now, because this is less than, these are open circles. So we have an open circle at negative 1, and we have an open circle at 3. Okay, now we need to find the vertex. Now I'm going to draw a line here to leave some space for our work and then leave space for the graph. Okay, now to find the vertex, we have the equation 2x squared minus 4x minus 6. Now, this is our A value, this is our B value, and this is our C value. Okay? Now, we know from our previous notes that H equals negative B divided by 2A. And let me write this. Vertex is H, comma, K. So B is negative 4, so it's negative 4 divided by 2 times A, which is 2 times 2. Well, that's a positive 4 divided by 4, which is 1. So H equals 1. Now, to find K, we substitute 1 back into here to find our K value. So K equals 2 times 1 squared minus 4 times 1 minus 6 equals, well, that's 2 minus 4 is negative 2 minus 6 is negative 8. Okay, so our vertex is equal to 1 comma negative 8. Now, why the vertex is important, because it's going to tell us if the parabola opens upwards or downwards. In this case, our vertex is 1, negative 8. So about right here. And we're just going to label that as V for vertex. Okay. Now, there's no line underneath, so it's a dashed line. Now, you'll notice that I'm approximating the points. They don't have to be exact. We're just sketching. And we're going to sketch. Okay. Sketch the graph. Now, it's less than, so we shade below. Okay. All right, go and finish up example number 1. Oh, camera got pulled there. That was crazy. And quick adjustment there. Okay. All right, now let's take a look at example 2. Okay. Now, we first need to find the zeros or x-intercepts. So we need to set 2x squared minus 5x minus 2 equal to 0. Okay. Now we're going to factor that using the reverse box method. So first term, last term, we know that 2x times 1x makes 2x squared. And we're trying to find the middle term. We're trying to find the two numbers that multiply to negative 2 and combine to be negative 5x.
Students and teachers, we are all clear. Again, we are all clear.
It's good to know we're all clear, so let's continue. Okay, so now let's find all the combinations that make negative 2. Okay, so 1 times negative 2 is negative 2, and 2 times negative 1 is negative 2. All All right. Now, we have to multiply the first number by 2 and the second number by 1 and try to find a combination of negative 5. So 2 times 1 times 1 times negative 2 is 0. That doesn't work. 2 times 2 plus 1, I almost forgot, there should be a 1 right there. 1 times negative 1, which equals 1. Oh, wait, let me tell you. Oh, I'm sorry. 2 times 2 is 4. 4 minus 1 is 3. Okay? Now, those are the only possible combinations. Since none of those have negative 5, we can say that this is not factorable. Since it's not factorable, we're going to have to find the x-intercepts using the quadratic formula. So we need to come back here. This is A, this is B, this is C. Okay? And then let's add the quadratic formula here since we have space. So x equals negative b plus or minus the square root of b squared minus 4 times a c. And I'm actually going to move the ABC down to here. So A, B, and C. Okay, divided by 2A. Okay. Now we're going to apply this to here to find the x values. Okay. So x equals negative b. So b is negative 5. So that's negative 5 plus or minus the square root of negative 5 squared minus 4 times the a value is 2 times the c value is negative 2 divided by 2 times 2. Okay, so x equals a negative times a negative is a positive, so it's positive 5 plus or minus the square root well, 5 squared is 25 plus, that's a negative 8, but then negative 8 times negative 2 is 16, so 25 plus 16 is 41 divided by 4. Now, we need to see if we can reduce the square root by perfect square. So let's see if we can see if 41 is divided by a perfect square. So let me go to the calculator here. Let's try 41 divided by 4. That's your first perfect square. Oh, press enter. Whoa, that's weird. I believe we have a calculator malfunction. So I'm going to reset this one and grab another one. Very weird. I've never seen a calculator malfunction that way in my entire life. So let's use this new one. So we're going to go to new document, no, add calculator. So let's do 41 divided by 4, control enter. That doesn't work. 41 divided by 9, control enter. 41 divided by 16, control enter. Excuse me. 41 divided by 25, control enter. 41 divided by 36, control enter. You can see here that 41 is not divisible by any of the perfect squares, so we're just going to have to leave that as a square root of 41. Okay, so then x equals 5 plus the square root of 41 divided by 4 equals, so let's plug that into our calculator. So control divide, 5 plus control square root of 41 divided by 4, press enter. Let's round to one decimal place, so that's 2.9. So our x-intercept is 2.9 comma 0. Okay. All right, now let's look at the next one. X equals 5 minus the square root of 41 divided by 4. Well, that horizontal line looked terrible. Let's try that again. Okay. Equals. So now all we have to do is highlight this, press enter, change the plus to a minus, and it's negative, let's say, 0.4. Okay, so negative 0.4. So the x-intercept is negative 0.4 comma 0. Okay. All right. So now let's sketch our graph, or not sketch our graph all the way. Let's get our x-intercept. So we have a point here at negative 0.4, and then we have x-intercept at, or point at 2.9 comma 0. Now they are closed circles because there's a line underneath. Okay, so let's make those bigger. So closed circle because there's a line underneath. Okay. Now, again, we're just going to draw kind of a slanted line here to leave a space for work to find the vertex. Right, so let's find the vertex. Which, again, we know the vertex is h comma k. Right, and then from before, we need the A, B, and C value. So A is 2, B is negative 5, and C is negative 2. Now, we know from the previous problem that to find h is negative b divided by 2a. So that equals a negative 5 divided by 2 times 2, which, let's just use our calculator here for that. So then that's control divide, negative 5 divided by 2 times 2, which is 5 divided by 4, which control enter, which is 1.25, but let's be consistent, let's round to one decimal place, so 1.3. Okay. All right, and let me rewrite that a little bit better. All right. So now let's find k. So k, we substitute the 1.3 back into the original equation. So that's 2 times 1.3 squared minus 5 times 1.3 minus 2. So again, let's just use our calculator. Okay, so then that's 2 parentheses 1.3 squared minus 5 times 1.3 minus 2, and that'd be negative 5.1. Okay. Okay. So V, our vertex, is equal to 1.3 comma negative 5.1. Okay. Now, the reason why the vertex is important is it tells us if it's opening upwards or downwards. Okay. So 1.3 negative 5.1 is right here. That's our vertex. Now, there's a line underneath, so we know this is a solid line. And it's greater than, so we shade above. So we shade here. Okay. All right. Go ahead and finish up example 2. And now we're going to turn the page over. This is one of the rare times we have examples on the back of the page. Okay, example 3. Okay, solve each inequality and show the solution on the number line. Okay. Now, these are slightly different in that we don't need the vertex because we're just trying to find out what the solution is on the number line. Okay, but we do need to find the solutions being the x values because this is, we consider the horizontal line the x-axis. Okay, so we need to find out what values are going to cross on this. Okay, so same thing here, except for you need everything on one side. So we're going to add 1 to both sides. You need all the numbers on either the left side or the right side. So now we have 2x squared plus 3x plus 1 less than 0. Or I should say, yes. But the 0 is there because we're trying to find where it's going to cross the x-axis 0. But let's rewrite this with the 0 being the y value. So y greater than 2x squared plus 3x plus 1. Okay. All right. So we're going to factor using reverse box method. Excuse me. So first term, last term, and our middle term is 3x. Now, I'm going to make a slight, before we move on to here, I want to actually address something quick, and I'm going to need to erase this and move it over a little bit for what I want to explain, okay? All right, so this is still 2x squared plus 3x plus 1 less than 0. Now, I need to step back because I want to make sure you understand why I was able to write y there. For one, we're substituting the y for the 0 because we need inequality. But I'm going to rewrite this this way. If I flip my page over, technically I can write that as 0 greater than 2x squared plus 3x plus 1. That's what I'm going to do. Okay. So now this is 0 greater than 2x squared plus 3x plus 1. And you can see that when I get it blurry, that these are the same except for I'm plugging in 0 for y, because if it's a point on this line, then the y value is 0, okay? All right, so we know that 2x times 1x gives you 2x squared. Now we need to find all the combinations to multiply by 1. Well, that's real simple. There's only one combination that makes 1. 1 times 1 is 1. Okay, now we need to multiply 2 by the first number and 1 by the second number and see if we get a combination of 3. So 2 times 1 plus 1 times 1, well, that's 2 plus 1 is 3. So our factors are plus 1 and plus 1. Okay, well, let's check to make sure it works. 2x times 1 is 2x. 1 times 1 is 1x. 1x and 2x is 3x. This works. So our factors are 1x plus 1 equal to 0, and 2x plus 1 equal to 0. Okay, so now we solve for x. Subtract 1 from both sides. X equals -1. So our x-intercept 0 is -1 comma 0. And then subtract 1 from both sides. So you get 2x equals -1. Divide both sides by 2. So x equals -1 divided by 2. So then that is, and let's just go ahead and convert that to decimal. So that'd be -0.5 comma 0. Okay. So now, you notice both of our numbers are negative, so we can put our 0 here on the number line. And then we have, there's no line, so we have an open circle at, and we can make tick marks. So this would be a half, 1, 1.5, 2. So this would be -0.5. So we have an open circle here. And we have an open circle at, and you know what? The tick marks actually make it a lot messier. So I'm just going to put the -1 right here. That makes it a little bit, okay? Now, we know that since it's greater than, the parabola opens upwards and there's no line, so it's a dashed line. We don't need the vertex because we don't care how low the vertex is. All we need to know is that it's opening upwards. It's greater than, so we're shading above here. So that means our solution under the number line is between -1 and -0.5. So to write that as an inequality, we would write that as -1 less than x less than -0.5. You could also write that in interval notation, that is parentheses -1 comma -0.5. Okay, go and finish up example 3. All right, let's take a look at example 4. Okay, now, just like before, we need to subtract 3 from both sides. Okay, so then that's x squared minus, oh, I'm sorry, plus 5x minus 3 greater than or equal to 0. Now we can rewrite this as 0 less than or equal to x squared plus 5x minus 3. And the reason why we want to rewrite that is we know that our y value is 0, but we want to write the inequality with a y so we know which way it's opening, up or down. So y is less than x squared, less than or equal to x squared plus 5x minus 3. Okay? All right. So now we need to solve for the x-intercepts using the reverse box method. So we know first term is x squared, last term is negative 3. And we know we want the middle term to be 5x. So we know x and x make x squared. Okay. All right, so now we need to find all the combinations to make negative 3. Well, we know 1 times negative 3 is negative 3, and 3 times negative 1 is negative 3. Okay. So we need to see if the combination combines to be 5x. 1 minus 3 is negative 2, and 3 minus 1 is positive 2. None of these combinations will give you 5, so we can say that this is not factorable. Okay, since it's not factorable, we're going to have to solve using the quadratic formula. So we want to first find out what A, B, and C is. So A is 1, B is 5, and C is negative 3. Now for reference, let's just go and write down the quadratic formula right here. And before we go on, I need to rush over to the calculator or to the pencil sharpener to sharpen pencil, and I'll be right back. I apologize for that delay. So x equals negative b plus or minus the square root of b squared minus 4 times ac divided by 2 times a. Okay? So now we're going to plug these numbers into that formula. So x equals negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 3 divided by 2 times 1. Okay? So x equals negative 5 plus or minus the square root of, that's 25, negative 4, negative 3 is positive 12, so 12 plus 25 is 37 divided by 2. Now, we need to see if the square root of 37 can be reduced by perfect squares. So let's try 37 divided by 4, control enter, that doesn't work. 37 divided by 9, control enter, that doesn't work. 37 divided by 16, that doesn't work. 37 divided by 25, that doesn't work. So 37 is not divisible by a perfect square. So we have x equals, and I think from here, I'm okay if you just plug that into your calculator and get your x values, okay? So let's go ahead and do that. So that's control divide 5 plus the square root of 37 divided by 2. Enter. Let's round one decimal place, so that's 5.5. And then we're going to highlight, enter, change the plus to a minus, and that's negative 0.5. So negative 0.5. So you have a point at 5.5 comma 0 and negative 0.5 comma 0. Okay. All right. So we're going to put those numbers on the number line. Since we have a number on the negative and positive, let's put the 0 in the middle. Now, we see here that there's a line underneath, so it's a closed circle. So we have a closed circle at negative 0.5, and we have a closed circle at 5.5. They don't need to be an exact space on the number line. It has to be correct. The negative has to be on the left, the positive has to be on the right, okay? Because we're just sketching. Okay. All right. Now, we know that if it's less than, it's going to open downward, okay? We know it's a solid line. Oh, wait a second. No. All right. I'm kind of glad I made this mistake because you might make that mistake. I confuse the inequality with the way the graph opens, okay? The A value is positive, okay? So it opens upwards. Okay? The shading is what the inequality has to do with. Since this is less than, we shade below the graph. Okay? Now, that tells us our solution on the number line is here and here. So let me just make sure I'm clear. The shading is because it's y less than, okay? This is because A equals 1, which is greater than 0. Okay? All right, so your solution is x is less than or equal to negative 0.5, or x is greater than or equal to 5.5. Okay, now in interval notation, that would be negative infinity to negative 0.5 bracket, or bracket 5.5 to infinity. Okay, go ahead and finish up your examples and start working on your assignment, and have a wonderful Wildcat day.